Hi guys, in this tutorial we're going to look at E. We continue looking at the series of an engineer trying to fix a bridge, and this time around we're looking at the friction at the bottom of the wedge there. Now in the previous case we had to draw a free body diagram for the slab bar, but now to determine the friction at the base of the wedge we'd have to draw a free body diagram of the wedge itself. So this is the wedge. Now, of course, we know the angle and so on. Remember, for the slab bar, we assumed friction was going upwards like that. So because of that, we found what friction was, of course. Now, what we have to see is that when it comes to the wedge, it will now mean that friction will have to go vertically downwards, opposite to how it was behaving for the first one. So this is that's 0.11 NB. And then next up at the bottom here. So at the bottom here, this wedge is trying to be pushed backwards. So friction has to prevent that from happening. So friction has to be going in this direction. And this is going to be, I'll take this as NC, the C being the bottom there. So, but of course we need the coefficient between the wedge and the ground there. So this is going to be the normal at the bottom multiplying the coefficient of friction between the ground and the wedge there. So of course this NC has to be the normal force from the base or from the ground acting onto the wedge. This is what NC is. So this is just now a free body diagram for the wedge itself. Now we just need to find this coefficient of friction between the wedge and the ground. So if we go back to the information given, that is given. So where is it? Somewhere here. Where is that? So mu between the wedge and the ground. So between the wedge and the ground, we have 0.29. So the coefficient of friction between the wedge and the ground is 0.29. So when we come to our information here, so this is going to be the frictional force here is going to be given. Let me write it like this. So the frictional force at the ground is going to be given by 0.29, the coefficient of friction between the wedge and the ground, multiplying the normal force at the bottom there, NC. So we already know what this one is from the previous calculation. Now, how are we going to work out this problem? Well, all we have to do here now is sum of forces. We won't even use rotations here. We'll just use sum of forces. But for sum of forces to work, everything has to appear either in the x-axis or in the y-axis. We'll use this setup for up being y, horizontal being x, implying that we need to break down this force of friction. So I think we already found this force of friction, 0.11 multiplying NB. So I think we did get what this one was in our previous calculation. And that was, what was that? It was 150 kilonewtons. So this was it 150, 180? That's 180 kilonewtons. So 180 kilonewtons. So we need to express this in terms of x and y into its components. So again, you have to do that. Figure out the angle that you can use or that relate as much as possible to what you've been given. If you know this angle, it becomes the same as this angle. And if you know this angle, then you can use that to get the components. So I'll get the vertical component to be a component like that, and the horizontal component to be a component like this is not like that. The horizontal component, the vertical component, let's see what I'm doing. Not that, again, I'm using the same triangle as the other ones. So the horizontal component will have to be a component like this, and the vertical component will have to be a component like this, so that we form our right angles somewhere here. So we see that this angle here, we can relate it to the opposite, relate it to the adjacent. So here on top, it's side by side, so we're going to use cos. It's going to be that 180, and then we're going to have cos our angle theta. And this side, it's opposite, so we're going to say 180, and then we're going to have sine theta. So let's do the math now. Sum of forces. Let's start with sum of forces in the y-axis is equals to 0. So in the y-axis, we see only two forces, the 180 sine theta and the NC. So NC is going up, it will be positive, minus, and then here we're going to have the 180, and then there we have 180. Just confirm the angles there. So this is 180 sine theta, and that these are the only two, so this is equals to 0. Yeah, those are the only two. Okay, so from here we end up with NC is equals to that's 180 sine theta. So again, we do know what our theta is in this case. So the wedge angle, I think it was 30 degrees if I do recall properly. That's 180 sine 30. And sine 30 is half of 180 becomes 90. So this becomes 90 kilonewtons. Okay, that is NC. Now next up, since we now know what NC is, we can easily get what the force of friction is. Force of friction was just 0.29 multiplying NC. And since NC is 90, so this is all we're going to have. So you multiply those two, that's 90 multiplying 0.29. Okay, that's 90 multiplying 0.29. We get 26.1. So there we get 26.1 kilonewtons. Okay, so yeah, this is all you had to do. This is the friction at the bottom. So yeah, I hope you found this helpful. If you did, leave a like so that I can upload the next one. Now guys, verify these values, verify my calculations. The methods are okay, but just in case I made a silly mistake, I'm going to be able to see it. Alright, let's see you guys in the next one.